All right, we're going to start chapter 3. Chapter 3 deals with the derivative. And we're going to look at all different ways, shapes, sizes of what the derivative really means. Actually, what does a derivative mean? Have you ever heard that word before? What does it mean? How do you mean? Oh, yeah, I saying that derives from. Kind of. Yeah, you look at that. But what it really means is how something changes. If it's derivative of, that means it's a change of. It's a permutation of. We started off in chapter 2, the very first part, talking about this formula. What is that formula of? No. Anybody in a Calculus 1 class? This is the equation for a slope from algebra. Because what this requires are 2 points. You have x1, f of x1, and x2 at f of x2. Remember, f of x2 is the same thing as y2, f of x1 is the same thing as y1. But that only works if you have 2 points. Will that work for finding the slope of a curve? No. Because if we found 2 points in a curve and we connected them, we just found the slope of the secant line. And if we want the slope of that point there, we have to move these closer and closer together. How do we do that? Well, since we want the slope at one point, we defined this distance as h. H equals the distance between x1 and x2. Or another way you can look at it. If I start off at x1 and I add h to it, I'll get to x2. So x1 plus h equals x2. The same thing. It then derives this. So this equation on the bottom became h. We don't have 2 points anymore. We only have 1 point, x1. So we need to write x2 as a function of x1. So we have x1 plus h equals x2. That's what we did here. Here's x1. If I add this distance, then I get to x2. So anywhere I see an x2, I put that in its place. So it's f of x1 plus h minus f of x1. But that works for any value x I pick. So from the slope, which we need 2 points, we now define something called the difference quotient, where we're looking for the slope at 1 point only. But how do we get rid of h? H is a distance. Eventually, how far do we want x1 and x2 to be apart? Remember, we only want the slope of that point there. So how wide do we want them to be apart? 0. So we need to see, how do we make h go to 0? So we take the limit of this function f of x over h as h goes to 0. So what that means, at any point x that I pick, I can plug into this difference quotient, take the limit as h goes to 0, and I have the slope of that curve at that point. It's got another name. It's called a derivative. Derivatives refer to slopes at a point and the rate of change at a point. At a given time, I should say. So this is what we're starting off to talk about. It's the derivative. But it means something more than that. The derivative is the slope of the line tangent to a curve at any point x. You really don't need to have your laptops open during lectures. I mean, unless you're doing your work, then you're gonna have to be in lecture. So it's either one or the other. So what we're looking at here, yes, we're talking about the slope, but the slope of what? The slope of the tangent line at that curve, at that point. Okay. Remember I told you, calculus is nothing but turbo algebra. Yes, we're going to start off finding derivatives this way, but then there are shortcuts we can use to find the derivative of a function at a given point. Let's look at example 1. Example 1 says A, find the slope of the curve y equals 1 over x at x equals a, where a does not equal 0. The slope of that. And then what is the slope at x equals -1? Then we look at where does the slope equal -1/4? And finally, what happens to the tangent line to the curve at the point 1 over a as a changes? Happens as a changes. So let's look at A. Well, it helps to see the graph. What does 1 over x look like in the graph? The library of function, it looks like this. It's got a horizontal and a vertical asymptote at the origin, at the x value, the origin, and y value. So, A. The slope. What's the formula for slope we're using? The limit as h approaches 0 of f of x plus h minus f of x over h. We're doing it at x equals a. So we have the f of x. F of x is equal to 1 over a, or x. I'm going to put that in shortly. What do we need? To use this equation, what else do we need? We need this function. We need the function x plus h. So it's 1 over x plus h. Now we can plug everything into the equation. The limit as h goes to 0 of 1 over x plus h minus 1 over x over h. Then it's saying when x equals a. Well, we can go ahead and work this out first and then get the function. So how do we simplify this equation? What do we have to do? The what? How do you mean?
Multiplied by 1 over x plus h minus.
Ooh, that'll give us a quadratic equation up the top. So no, we have to first simplify. Let's first get common denominators. Treat the both top and bottom separately. This one needs an x, so we have x over x. This one needs an x plus h over x plus h. So that gives us x plus h, the common denominator on the bottom, x minus x plus h on top. So we can distribute. We have minus 8 x minus h. The x's cancel. So on top, we have x plus h negative h. Remember, the bottom here is h over 1. So we have a fraction over a fraction. Remember, whenever you have a fraction over a fraction, take the top fraction, leave it alone, flip the bottom, and multiply them together. So this I'll multiply to 1 over h to the top. Negative h x plus h times 1 over h. Now flip the bottom and multiply it. Simplify. Before you multiply fractions, always simplify. This h and this h cancel. Leave it 1. So I have the limit as h goes to 0 of negative 1 x plus h. We can't do anything else algebraic here, really. So make h goes to 0. And that gives us 1 over x squared. When x equals a, we get negative 1 over a squared. That's my slope.
Could we just cancel out A?
Well, because h goes to 0. H goes to 0, so it's gone.
Oh.
Fuck this. Okay. Okay, now that's a. What is the slope? Now, a part 2 says when x equals negative 1. What is the slope at x equals negative 1? So the slope of negative 1 over x squared is negative 1 over negative 1 squared. Negative 1 over 1 is negative 1. The slope equals negative 1. B, where does the slope equal negative 1/4? Where does the slope equal negative 1/4? So we know that the slope, the equation, is negative 1 over x squared. That's what we calculated over here. So we set negative 1 over x squared equals to negative 1/4. So when does x squared equal 4? X equals positive or negative 2. So the question asks, where does it equal negative 1/4? What's the answer? It's asking for 2 points. The slope equals negative 1/4 at, well, first off, we need y equals 1 over x at x equals plus or minus 2. When x equals 2, when x equals negative 2, so there's 1 point, there's 2 points. So they equal at 2 1/2 and negative 2 negative 1/2. So at negative 2, it's negative 1/2. At positive 2, it's at positive 1/2.
Can you show where you got 1/2? Was it on the previous?
Well, remember, my function is what, well, that's the original function.
Oh,
So I just now plug in each one of these. I plug in positive 2 on the bottom and then negative 2 on the bottom. Yeah, whenever you deal with points on the graph, go back to the original equation. So see what happens when A changes. What happens when A changes? A represents the point on the x-axis. Well, again, looking at this graph, what do we notice about the curve, the slope of this curve anywhere? Well, yeah, it could approach 0 if we go this way. But as we go this way, remember, as we're reading left to right. So as we're reading to the right, what happens to the slope? They're always going to be what? Positive, negative, or 0? No. 0 slope is a horizontal line. This one, we just found out, was negative 1/4. This one here is negative 1/4. This one's also negative. This one's negative. This one's negative. This one's negative. Throughout the entire curve, the slope will be negative. But as x approaches, or as A approaches 0 from the left, what happens to the slope of the curve? It becomes vertical, undefined. It's a vertical slope. As A approaches 0 from the right, what happens? It's also going to be vertical. As A approaches this way, the slope is going up, 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 up. So it's going to be negative here. It's going to be negative here. So as A goes to 0, it goes vertical slopes. As A goes to infinity, As a goes to positive infinity, the slope goes to 0. As a goes to negative infinity, the slope goes to 0. How do we know that the slope is negative everywhere? What's the formula for our slope? So if A is negative and you square it, it becomes what? And it's a negative still. If A is positive and you square it, it stays positive. It's still negative. A cannot be 0. You can never get to 0 because that's an asymptote. So because of this, the slope is negative at all points. So the only thing, as we move to the right, it goes from 0 slope to an undefined slope. And then it starts from an undefined and goes to 0, depending on which direction you're going. So that's the first part. Remember, derivatives are also rates of change. The rate of change is the derivative at a point. So we're going to be defining our derivatives like this from now on. Well, for the short time being. Where x could be any value x we're looking at. Next example. So let's look at example 2. In examples 1 and 2 of section 1, we studied the speed of a falling rock freely from rest near the surface of the earth. The rock fell 16 t² feet during the first t seconds. And we use a sequence of average rates to over increasingly short intervals to estimate. That was our example from 2.1. So what is the rock's exact speed at x equals 1? What is the exact speed? Speed of the rock is the rate of change of the rock. The difference of y over difference of x. So f of x1 is 16t². We have to figure out f of x plus h, which is our x2. What's that going to be? So in place of t, I put this. And it's squared. So the speed, which is the derivative we're going to talk about that again today, is speed is the derivative, it's the change of position. Think about it. From this position to this position, it's the change of positions over change of time. That's what a derivative tells us. As h goes to 0. Now, since we're asking for 1, instead of x, we can just put 1 in there right now if we wanted to. So we have the limit as h goes to 0 of 1 plus h minus f of 1 over h. What is f of 1 plus h? Well, here's f x plus h, so we use this formula. 16 1 plus h squared minus 16 1 squared over h. This is where we plug in our functions. This is the x plus h, which was 16x plus h squared. What do I have to do next? Multiply what? No. We have a square. We have to get rid of parentheses. We have to square it first. We have to first do 1 plus h squared, which is 1 plus h, 1 plus h. 1 times h, 1 times h squared. So it's 1 plus 2h plus h squared. One plus 2h plus h squared minus 16. That's 1 squared. Next, let's distribute, get rid of the parentheses up on top, combine like terms. Remember, whenever you do the quotient rule, whatever's after that minus part has to cancel out with something. So we have the limit of h goes to 0, 16 1 plus 2h plus h squared minus 16 over h. So I distribute. H goes to 0. 16 plus 32h plus 16h squared minus 16 over h. Combine like terms. 16s cancel. Thirty-two h plus 16h squared Factor the top. So they both have a 16 and they both have an H. 2 plus H. The H's cancel. We have 16, 2 plus H. H goes to 0. So we get what? .32 feet per second. And that's the speed. At x equals 1 or t equals 1. Pretty straightforward. That's section 1. So what is a slope again? What is a slope? What does it do? It finds, well, I'm sorry, what is a derivative? I gave you the answer. It's the slope of what? It's the slope of the line tangent to the curve at a point. So, because now, why do we need to know that? Because eventually we're gonna have to know what's that equation of the line tangent. So we have the point, we have the slope, algebra tells us the equation of the line.